Unvalidated redirects and forwards is another one in the OWASP top 10. It does come in last place, so it is the least risky of those top 10 risks, but it still makes an appearance, and it has done for several versions now. The main thing that stands out here in their risk rating is detectability. It's very easy to find when there is a risk of an unvalidated redirect and forward. And in fact, this is a pattern that you'll see in many different applications. Part of what makes this one a little bit contentious is that there are some valid use cases for having an unvalidated redirect and forward. Let me show you a legitimate use of it, and then we'll go and exploit it. Let me demonstrate how a redirect or forward should function under normal operating circumstances. We're on our insecure site. I'm currently logged off. I've got a log in link on the navigation bar. Now imagine I tried to go to an authenticated resource. So for example, let's say I tried to go to this URL. So have a look at it. It's this nice semantic pattern again. I'm trying to go to account, user profile, number 1. This is the resource where you edit your account. But I'm not logged in. So watch what happens as I try to load this page. I'm taken to the login page, but have a look at the URL. It's got a query string called return URL, and in that return URL, there's a URL encoded value, so the forward slashes are being converted to %2fs, that refers to the original URL that I tried to load. So watch what happens now when I log in. Email address, password, login. You see how I'm now on that edit profile page? So what's actually happened is after posting my credentials to the login page, including that redirect URL query string, it's authenticated me and then returned me to the page I was originally trying to access. That's neat. It's a nice little usability feature. But let's now exploit that. So I'm going to go and log off from my account. And now I'm going to go up to the address bar and I'm going to paste in a URL that someone has given me. This is pretty long, so let me jump back to the start. And now you can see the entire URL. Now there is something here in the return URL, but it's an obfuscated value. In fact, it's URL coding of every single character in the query string. Now here's the thing in terms of this being an attack vector. I, as the victim, have received this URL. When I look at it, I see a domain that I trust. I know this website, hackyourselffirst.troyhunt.com. Now imagine that's your bank, or a government website, or another address that you have confidence in. If someone gives you that, you're going to have a higher degree of confidence in the integrity of what comes after you load that link. But let's do that. Let's now actually follow that link. Okay, so it wants me to log in. Now we are actually on the legitimate site. We can still see hackyourselffirst.troyhunt.com in the address bar, so it must be okay. Let's now enter my email address, password, and log in. Now as soon as I do this, we can see a file has downloaded. It's a file called malware.exe. And what you may have actually noticed is that the status bar very briefly showed evilcyberhacker.com. So that's our malicious website again. Now here's how this happened. Take a look at the URL in the address bar now, and particularly that return URL. Google Chrome has automatically translated most of the characters from their URL encoded values back to the original value. And now we can actually get a sense of what's happening. It's gone to evilcyberhacker.com/malware.exe. So what we have done as an attacker is use the redirect of the login page in order to send the victim to a URL serving malware. So we're looking at a malicious file that has been downloaded, but we're looking at a trusted domain in the address bar. And this is really the crux of an unvalidated redirect and forward. It's exploiting the trust that individuals have in the domain of a website in order to serve them malicious content. Now in this case, Chrome has obviously highlighted that this is not a commonly downloaded type of file and could be dangerous, which is great for Chrome. Not all browsers are quite as obvious, and of course, not all attacks on an unvalidated redirect and forward are quite so blatant. They're usually not called malware.exe. It might instead take the victim to a phishing page or another potentially malicious resource. So that's an unvalidated redirect and forward in action. Now, the defense against this is usually pretty straightforward. In a case like this, it should only be able to redirect to local resources. You should not be able to redirect to an external website. There are other use cases where you need to redirect to other external websites, in which case it's better to create a whitelist of allowable websites. You can then still use this URL pattern, but only if the return URL in this case is a trusted site. However, there are also use cases where that redirect may need to be any arbitrary external site. You'll often see patterns like that with, say, social media sites or online email providers, where they want to redirect you through one of their resources when you follow an arbitrary link that's been sent to you by someone else. In those cases, an unvalidated redirect and forward isn't even a bug. It's actually a feature. So you've got to be a little bit conscious about how valid this actually is as a security risk, but certainly this is how it can be exploited. Let's now move on and have a look at a totally different sort of risk, and that's exposed exception logs.